Okay, let's unpack this. Welcome to our deep dive where we really try to get to the heart of a topic for you.
Glad to be here.
Today we're looking at something, well, something in your fridge maybe. Farm-based yogurt. Specifically how it spoils, or rather, how spoilage is understood during transport.
Right, that trip from the farm to the store is critical,
Hmm.
especially for fresher, maybe less processed yogurts.
And we've got some research material, I understand, focused on this exact challenge.
Yeah, exactly. Some interesting work looking at how to model the impact of temperature changes on this kind of yogurt while it's on the move.
Okay, so our mission here is to pull out the key ideas. How are they actually analyzing this? Predicting spoilage seems, well, complicated. It's not just good or bad, right?
No, definitely not. And the really core finding highlighted in the source is their approach, the method they're using.
Which is.
They're using a mathematical tool, the derivative.
But derivative, okay, calculus flashbacks. Why a derivative for yogurt going bad?
Huh? Yeah. Well, think about it. Spoilage doesn't just happen at one steady speed.
Right, temperature changes things.
Exactly. It speeds up, it slows down. And the derivative is like perfect for modeling how that speed, that rate of spoilage, is changing at any given moment because of the temperature right then.
Ah, okay, so it's not just hot is bad, it's capturing how much faster it gets bad when the temperature ticks up a few degrees, that accelerating effect.
Precisely. It quantifies the rate of change of the spoilage rate,
Yeah.
so you get this dynamic picture.
Dynamic picture, I like that.
Yeah. It lets the research move beyond just simple correlations. They can build a model that adds up the impact of all the temperature shifts during the journey, hour by hour almost.
So it's much more powerful than just looking at the average temperature for the whole trip.
Oh, absolutely. The source shows this gives a much, much more accurate prediction of the final quality. Averages can really hide damaging peaks.
Got it. So this derivative model, does the source say what it reveals about the spoilage? Like, are there specific temperature points that are super critical?
Well, the source focuses a lot on the method itself, but this kind of modeling allows you to see those things.
Okay.
You can pinpoint thresholds where the spoilage rate really takes off. It helps understand that non-linear aspect, a small temperature rise, might cause big jump in spoilage speed.
Right, not just a little bit worse, but potentially a lot worse quickly.
Exactly. And it can help quantify the difference between, say, a short, sharp temperature spike versus being slightly too warm for a long time.
That makes sense. It's all about the dynamics. But I mean, transport involves more than just temperature, right? Journey time, packaging. Does the research touch on that?
Oh, for sure. Those are definitely part of the bigger picture in the research field.
Hmm.
But the strength highlighted here in this source is how they're isolating and analyzing that temperature-driven part so effectively using the derivative.
So really zooming in on one crucial variable.
Yes, and understanding its dynamic impact with real precision. It's about seeing how sensitive the yogurt's stability is to those temperature changes during transit.
And knowing that with such detail, that's important for, well, for us, right? Even if we're not driving the truck.
Absolutely. This kind of detailed analysis leads to better cold chain design, smarter logistics.
Which means less wasted yogurt.
Less waste, definitely. For the producer, the retailer, and potentially less spoilage even after you buy it. If the journey was managed better based on these models, it's about quality, efficiency, sustainability.
Okay, so wrapping up this dive then, the core takeaway from the source is seeing how quite sophisticated math, like derivatives, isn't just abstract. It's being used to model tangible things.
Like yogurt spoilage during transport, driven by temperature changes. It really highlights the power of understanding the rate at which things change, not just the change itself.
And connecting that to the bigger picture. Understanding these specific mechanisms, like how temperature drives spoilage dynamically, that's key for improving food logistics overall.
Fundamentally, yes. It's about using data, using analysis, to make that journey from the farm to your table safer and more reliable.
It does make you think. If you can use a derivative to model how temperature changes affect yogurt spoilage rates, what other everyday things, things affected by constantly changing conditions, could we understand better with that kind of approach?
Interesting question. Like battery life based on how you charge it. Or maybe even how quickly a room heats or cools.
Exactly. Lots of things change based on changing rates. Definitely something to chew on. Thanks for unpacking that with me.
It's my pleasure.